Okay, so when we're talking about standard form, because what we were looking at last time, I'm gonna put this up here. Just you don't have to have it. All right, this was vertex, or sometimes they call that graphing form. So what we're going to look at now is if it's in standard form. So when we're talking about something that's in standard form, again, they could put y equals, they could put f of x equals. That part doesn't really matter. It's basically going to be this. All right, so what we're going to have to do is we're going to have to take something that looks like this, and we're going to rewrite it so it looks like this, so we can figure out what the vertex is going to be. Because the way it is right now, we don't have any parentheses. We got all this extra stuff back here. We don't know what the vertex is. So again, we're going to take this, rewrite it, make it look like this, so we can figure out what our vertex is going to be. Because if we can get the vertex, everything else after that's going to be really easy when it comes off of it. So this, the A and the B and the C that we have here, those are all real numbers. That if they give you something like this, there's one thing you have to do to find the vertex. So again, we got to figure out what that vertex is, HK, because again, if we pulled the vertex out of this, it was the H and the K value. So again, we're going to go back and kind of find that one. So to find the vertex, which is the HK, the H value that's here is just going to equal the negative of B over 2 times A. Okay. Now, and when you see that in the book or on Math Excel, they don't put the parentheses here, but we're going to put the parentheses just to make things a little bit easier for us when we start plugging numbers in, especially if we're going to use calculators to kind of go through those. Okay. So, and then once you find out what this H value is that's here, to find the K value of the vertex, you're going to plug in the H value into the original equation. Okay, now the way the book does this, they kind of show you something different in this one. So if you're doing the help me problems on Math Excel or anything in those, the way the book shows this, and you don't have to worry about this, I'm just going to kind of write it down for you. So if you see this, you know what's going on with it. The book notation for vertex is going to be negative B over 2A, which is this number we've got here. And then they're going to do a comma and then F of negative B over 2A, where they take this number and plug it back into this F of X that equals this thing back here. So whenever you see this, if you happen to do the view an example or anything like that, just realize when you see that part that they're just still talking about the vertex. Okay, now somebody may be asking, and maybe not. We used A and B. Somebody may be saying, what about C back here? Okay, the good thing is when we do this one, that C value is the y-intercept. Okay, so there's an extra bonus with this one that, yeah, we got to work to find the vertex, but if there's any good thing from that one is the C value tells us what the y-intercept is going to be. All right, and then just one thing to remember. The A value that they give to you still tells you the direction of the graph. Just like we did with all the other stuff that was there, that the A value told you what it was going to do. So again, if the A is positive, the graph is going to look something like that. And if your A value is negative, it's going to look something like that. So that part doesn't change. That part's still going to be the exact same thing. And again, if it looks like this, the vertex is the bottom. The vertex is going to be a minimum. If it looks like this, where the A value is negative, the graph will look like that. That means the vertex is going to have a maximum. Okay, so that part doesn't change. The A value still tells you whether you're going up or whether you're going down when you're going to graph this. The domain is still negative infinity to infinity. The only thing that's different is for this part of it, we've got to figure out what that vertex is going to be because it's not going to be there. All right, so we're gonna do two examples, show you what this looks like, walk through both of those, and then everything else that we've got that will show it will be just some different version of doing one of those two things, but everything else will be basically the same as we go through that. All right, just like on the bell ringer, just like we did yesterday when we do these two examples. We're going to find the vertex, whether it's a max or min, and what that value is going to be. We're going to do the axis of symmetry. And because these problems are a little bit different than the ones that we were doing, we're actually going to add in one more thing here. We're going to add in the y-intercept. The domain and the range. And then we're going to write in vertex form. And then the last thing we finally get to do is we get to graph this thing. Okay, now it seems like a lot of stuff. We're going to do this, we're going to do that, this, but all that stuff, everything on this one spins around finding the vertex. Once we've got the vertex, we know what the axis of symmetry is. We know where the max or min is going to be. We know what the domain and range is going to be. If we've got the vertex form is really easy. Graph, again, once you got the vertex, the graph gets really easy. So the main thing we've got to do is just figure out what that vertex is going to be. All right, so here's the first one. 2x squared plus 8x minus 1. Okay, and for these, we're going to get the easy things out of the way first. We know that A value is 2. We know the B value is 8. And we know the C value is negative 1. All right, now, here's where we get the easy things out of the way first, because the hard stuff, we'll worry about that in a little bit. Here's where we get the easy things first. The A value is positive. It's still like 2 over 1, right? So in that case, we know that because this thing is positive, we know the graph has to look something like that. And if the graph looks like that, we know the vertex is at the bottom. We know it's got to be a minimum. Okay, so there's one of our answers right there. Whether it's a max or min, we've got that based on the A value. We know what the graph is going to look like. And then the other thing we can get off this one is the C value is negative 1. That is the y-intercept. And again, they'll probably make you write that as an order pair. So it'll make it 0, negative 1. All right, so that's the things you can get without having to just looking at it. We know what the A value is, which tells us which way the graph is going, and if we know which way the graph is going, we know if we got a maximum or minimum in this case. Okay, so we got to find the vertex. Again, the h is going to be, and again, we're going to put it in parentheses. It's negative b over 2a. So that's negative. Our b value in that case is 8 over 2 times our a value, which is 2. All right, so that's negative 8 over 4, which is negative 2. All right, and again, if you need to trust in your calculators a little bit more, if you're still not comfortable with all your positives and negatives here, again, just punch it in. And again, use your parentheses. And this is one of those things where if you use your parentheses, you really say it's really impossible to miss this one, but it's really hard to do this thing wrong. It's negative, negative 8 divided by, now here's where you got to be careful with this one. On the bottom, go ahead and make that a number. If you know what 2 times 2 is 4, go ahead and do that. So go ahead and just make that out to be that fraction. So it's negative 8 over 4, so you got your negative 2. So go ahead and double that number and get it to there, and then punch that in and go from that part of it. Just make sure, again, you've got your negative with that part, because, again, if that's negative, we'll show you that in here in a second, how it'll change that one a little bit. All right, so we got our h value. It's negative 2. To find the other number, all we're going to do is we're going to take this negative 2 that's here, and we're going to plug it back into the equation up here. So to get the k value, that's going to be the 2x squared plus 8x plus 1. And so we're going to take this negative 2, we're going to plug it in for x here, and we're going to plug it in for x here. All right, and as long as we've got all the calculators over there, and everybody's got a calculator that you can use, this is how easy this thing gets to be. We're going to put that negative 2 in the parentheses. And then everything else has to go on the outside of it. So it's 2 times negative 2 squared plus 8 times negative 2 minus 1. And that one, you can punch that in any decent calculator, and it will give you the answer without having to do much of anything at all. Okay, so we're going to plug it in just like it is. We're going to put in 2 parentheses, negative 2 squared plus 8 parentheses, negative 2 minus 1. There we go. So we got our answer, negative 9. And that way you don't have to worry about working it out, kind of slowing down on that one. Just let the calculator do the work for you. And as long as you use parentheses, you cannot miss that answer unless you just punch something in wrong. That part I can't help you. But if you use your parentheses, you can't miss that number. All right, so now we know that our vertex is at negative 2, negative 9. So again, that's our h and that's our k. So we got our vertex. All right, so we got our vertex. We know it's a minimum. Now if they ask for the min value, it's that number that you get there. So after you plug in this x value, the h value here, whatever this answer is you get, that's your minimum value. Let's see. All right, domain, again, domain, we know it's going to be negative infinity to infinity because that answer never changes. For your range, since that's the minimum, we get to start with that number. So we're going to start at negative 9, and we know the graph is going up, so it's going to go up to positive infinity. Okay, and we're going to put a sketch of the graph over here. All right, so we need to go negative 2, negative 9. Okay, so negative 2, negative 9 would put us right about there. And again, we know the A value was 2. So to get to the next number, we're going to go up 2 and then over 1. Up 2 and over 1. And there's our U-shaped graph we're looking for right there. Just ignore that dot in the middle. That was me when I put my pen down. So there's our point, and then there's our point. All right, now one of the little thing we got for this one on the graph, and we'll scroll back down a second. We know the y-intercept's at -1, so we know after we draw this U-shaped graph here, it's got to cross through at -1. So then we'd look something like that. All right. Oh, we didn't do the axis of symmetry, did we? Okay, so if we know that the -2 is our h value, that's our axis of symmetry. That's always just that x value, so it's x equals -2. All right, so we got vertex, we've got our max or min value here, we've got our axis of symmetry, we did the y-intercept way back up here, we've got our domain and range there, which spins off of our y value. What was the last thing we did? Oh, vertex form. Okay, so vertex form. To get that one, we got to make it look something like this where we're using our parentheses. So what we're going to do is we're going to take our vertex we've got back up here, this -2, -9. Then we're going to take this answer. And basically all you're going to do is you're going to plug in your vertex in here. So when the vertex was at -2, -9. So we're going to plug that number in here for the h and that number in there for the k. So that's x minus -2. That makes it x plus 2. And then that's a -9, so that'll make it there. And then the one thing I always forget when I'm doing this one, and I'm bad about doing this, we already know that the a value, I'll pull back up real quick. When you back up here, this a value was 2, because that's kind of like our slope. So we just need to put that a value back there to make it 2. Okay, so a lot of stuff going on, but again, it all goes back to finding the vertex. And then once we've got the vertex, then we just use that to find basically everything else that we need in the problem to get done what we need to get done. All right, one more and then we're done. Second base, good. All right, so for number 2, we're going to do y equals -x squared minus 2x plus 5. All right, same thing. We're going to find like all that stuff that's on it, just like we did in the first example. All right, but again, let's keep the easy things the easy things. We know that the a value in this case would be -1. The b value would be -2. And the c value is 5. And then again, one answer you can get on this one without doing anything at all is that whatever this c value is that's here, we know that's going to be the y-intercept. So it'd be it. And I think Math Excel is going to make you put the 0, 5 from the test. If you just put the 5, I'm okay with that. You don't have to necessarily put the 0. I'd like for it to be there, but as long as you got the 5, that's the main thing. All right, other question we got. Which way is the graph going? Up or down?
Down.
All right. Okay, it's going down. How do we know it's going down? Yep, there we go. A value is negative. It's less than 0. So with this one being negative, we know the graph has got to go down. All right. And if the graph is going like this, the vertex is at the top. So know the vertex is going to be max. So there's, a couple answers that you know that you should have just by looking at it. A value is negative, which means the graph is going down. So if the graph is going down, the vertex is at the top. That means it's got to be a maximum. All right, again, we got to find the vertex. So the h value of the vertex, that's negative b over 2a. All right, here's where the parentheses come in handy, because it's minus negative 2 over 2 times negative 1. And so people are like, what, does that negative always stay there? Yes, absolutely, every single time. It's always a negative on the outside of the parentheses. This one always has a 2 on the outside of the parentheses. So for this one, when you do the minus the negative, that makes that a positive 2. When you do 2 times negative 1, that makes that a negative 2. And then once you got those, that's where you can divide 2 and negative 2. So then the h value of the vertex is going to be at negative 1. Okay, again, to get the k value, we're going to take this negative 1 we've got, and we're going to plug it into this equation back up here. So that is going to go in there. Okay, and again, the big thing you've got to remember for this one is, wherever you've got the x, we're going to plug in this negative 1. You've got to make sure it's in the parentheses. And then everything else goes on the outside of parentheses. That negative goes on the outside, that negative 2 goes on the outside, that plus 5 goes on the outside. And if you do that, there's a 99.9% chance, of you getting this question right. Okay, so from there, use our calculator. And I'm going to slide this over so we can see our calculator here. And then, again, plug it in just like it is. That's a negative, or minus sign, sorry. That's minus negative 1 squared minus 2 times negative 1 in parentheses, and then plus 5. There you go. So we got 6. Okay, so the h value is negative 1. K value is 6, so that's our vertex. That's what we're looking for. It's at negative 1, 6. Okay, again, that's got everything we need on it now. So again, this x value, that's the axis of symmetry. That's x equals negative 1. We said back up here, we knew that was a max value. So this is going to be a max value of 6. And again, that 6 is going to help us out with the range. Again, if that's the max value, that's the biggest number. And we know if this thing is pointed down, it's going to go to negative infinity. So we're going to start at negative infinity, and we're going to stop at negative 6. Because then that's the max value. That has to be the big number. When we did this one, that was a minimum, so that made it the first number. So whatever this k value is, if it's the minimum, it's the first number. If it's the maximum, it's the last number. All right. Again, domain never changes. It's negative infinity to infinity. I probably won't ask you for domain on the test because it's the exact same answer every single time. I'll probably just wind up skipping that one. Okay. We already had the y-intercept back here, so we're good on that one. We got our vertex, we got our axis, got the max value, got the range. Let's see. I think that's everything. We got our y-intercept, max, min. We'll put it in vertex form here in just a second. We're going to go ahead and graph it. So we need to go to negative 1, 6. So 1, 2, 3, 4, 5, 6. All right, so negative 1, 6 will put us there. So negative 1, 1, 2, 3, 4, 5, 6, put you up here. The A value was negative 1. So again, we know we're going to go down 1 over 1. So we go down 1 over 1, that'll put us there. If we go down 1 over 1, that'll put us there. Again, if it's absolute value, it's a straight V shape, but because it's x squared, after we leave that point, we got to curve it just a little bit. Okay. Again, test-wise, I'm not going to make you draw the axis of symmetry. Math Excel might make you draw the axis of symmetry. If you do, you just make it a dashed line right through the middle. Okay, and then the last thing, oh, we got to get vertex form. So vertex form is we're going to take this thing and plug it back in here to this. Again, the vertex was negative 1, 6. So again, that negative 1 goes on the inside. And if you do minus a negative, that will make it a positive. That number stays the same. And then our A value from way back up here was negative 1, or just a negative. So then we need a negative right there. Okay, if you put the 1, that's great. If you don't put the 1, that's great too. That 1 that's there is kind of optional. If you want to put it there, you can. If you don't, you don't have to.